Hey there, in this video we are going to look at long division. So we will specifically look at long division with whole numbers and with decimals, and then we will get into a little bit more of complex long division in the next video in part 2. So this is just part 1 for now. Long division is a very convenient way to divide any two numbers. Its downside, however, is that it can be time consuming. Therefore, we typically only use this when we can't do the division in our head as mental math, or if we're not 100% sure about what our quotient is, which is the answer to the division problem, and doing it in our head. So looking at the example we see down here, which we will do here in a minute, 625 divided by 5, I want to talk about the vocabulary a little bit. So the number that we are seeing on top of this fraction is going to be your dividend. So 625 is your dividend. That is what you are dividing by another number. So we are dividing by the number 5. So 5 is going to be our divisor. And then our answer is going to be what we call our quotient. So on number 1, we have 625 divided by 5. 625 divided by 5, we will set up in our long division box, and that's going to be 625 underneath the box and 5 on the outside to the left. So the 625 is our dividend, 5 is our divisor. Now our answer will go on top above the 625. So to start, we want to look at this first term here, or this first digit here, and this number over here in the divisor as a whole. So we want to know, can 5 divide evenly into 6? If so, we would put that number up top. So for example, if this number out here perfectly divided into this first digit here, we would put whatever the answer was when we did that division. Unfortunately, 6 does not divide by 5 evenly. So we have to look at what number times 5 is going to give me the closest number to 6 without going over 6. So if I start with 1, for example, 5 times 1 gives us 5, and 5 is not over 6. But if I went on and did 5 times 2, that would give us 10, which goes over 6, and so that does not work. So 1 is going to be the number that we put up top above the 6, because 5 goes into 6 one time. Now we do multiplication. So we do 1 times 5. 1 times 5 is 5. We subtract down that column. 6 minus 5 is 1. Once we get to that point, then we go ahead and we bring down our next digit. So we do want to make sure, one thing to check here at this point is to make sure that you pulled out enough of the divisor. So in this case, there's only 1 times 5 to get 5. But if we were left with a number that was bigger than this divisor here, that means we didn't actually pick the largest number to go here, which means we would need to go back and raise that number in order to get a difference that is smaller than our divisor. So that's just something to check as you're doing it. So once we check, yep, this is smaller than our divisor, then we bring that 2 down, that next digit down, and now we have 12. So we'll be looking at 12 and 5, and we want to ask ourselves, essentially 12 divided by 5, is that a whole number? Unfortunately, 12 divided by 5 will not come out to be a whole number. So then we go back to the process that we just did over here. So for example, 5 times 1, that gives us 5. 5 is smaller than 12, but we can also do 5 times 2. 5 times 2 is 10. That is still smaller than 12. We haven't reached over that 12 yet. Now, if I went on and I did 5 times 3, that would give me 15, which has now reached past the 12 that we have right here. So the biggest number that I can multiply 5 by to keep it under this 12 would be the number 2. So I'm going to put a 2, always lining up from left to right over the left digit, next digit, so on and so on. So now we have 2 times 5. 2 times 5 is 10, so we put that under the 12, and we subtract. You can do 12 minus 10 as a whole. You can do 2 minus 0 and get 2, and then 1 minus 1 and get 0, which we don't really need to put there. Either way is fine. Again, we took as much as we can out of it because we're left with a number smaller than our divisor. So then we can go ahead and bring down that next digit from our original dividend. So we bring down the 5, and now we're looking at 25. So this time we have 25, and we are dividing 25 by our divisor to see if that divide evenly. 25 divided by 5 is 5. So in this case, I don't need to figure out what do I need to multiply 5 by to get me closest to 25, because it is evenly divisible. So 25 divided by 5 is 5. So we'll put a 5 up here at the top. Now, once you have filled in all of these spots at the top in the quotient spot, meaning every digit above each of the digits in the dividend is filled in, okay? Once you've done that, and we end up with a 0 down here, which I'm going to show you in a second, that's how you know when you are finished. So we do need to still multiply 5 times 5, and that gives us 25. And then we subtract, just like we've been doing. 25 minus 25 is 0. And now I can say for sure that I am finished because I have filled in all of the spots in the quotient line. And when I went ahead and multiplied the 5 by 5 and subtracted it, I ended up with 0, which means there is no remaining value or no remainder, which we'll get more into what happens if we don't end up with 0 there once we've filled in all of those digits. So our answer on this one is 125. So now we are going to look at division with decimals. So there are 3 possible scenarios. We could see if the divisor has decimal digits, if the dividend has decimal digits, and if both the divisor and the dividend have decimal digits. Now I'll remind you, if we are looking at a fraction for division, the dividend is going to be the top number, the numerator. The divisor is going to be the bottom number, which is our denominator. And then our answer that we get out of that will be our quotient. So we are going to work through the first 2 examples, and then I will talk through what happens if both spots have decimals. So first one we're going to look at, calculate the following quotient. So 248 divided by 0.8. So if you look at this, our decimal is in our bottom number, what we're dividing by, which is the divisor. So I'm going to make that note here. Our decimal is in the divisor. So when the decimal is in the divisor, we want to go ahead and count our decimal places. So we see here that there is 1 decimal place. So I'm going to make that note for later. So 1 decimal place. Additionally, we want to move the decimal in both numbers to the right 1 place. So essentially, we are going to multiply the bottom and the top by 10 so that there are no more decimals in either one. Now, the top never had a decimal, but the bottom did. So if I multiply by 10, because that's 1 decimal place, that'll move it to the right 1 decimal place. On the bottom, I have to do the same thing on top to keep this as the same quotient, the same answer in the end. So I move this to the right 1 to be 8 on the bottom. But if I do that, I need to move where the decimal's at now to the right 1, and I'll put a 0 there. So that's going to be 2,480 on top divided by 8 on bottom. So again, we moved that 1 decimal place to the right because there was 1 decimal place or 1 decimal point in our denominator. If there had been 0.84, we would move the decimal to the right twice on the bottom and to the right twice on top so that we no longer have any decimals on top or bottom. So now that we've done that, we can go ahead and set up our long division, 2480 divided by 8. And we're going to start with this 2. Now, we're going to treat it just like the last one that we did. We're going to look at our 2 and look at our 8. And we want to know, what is 2 divided by 8? So in other words, does 8 divide into 2? Unfortunately, 8 does not divide into 2 because it's already bigger than 2. So what we do in that case is then we look at the first 2 digits together. So 24. Now, 8 does divide into 24, and in fact, it does work out perfectly. So 24 divided by 8 will come out to be 3, exactly 3. So that means we can go ahead and put 3 up here. Now, because we're doing this with the 24 and not just the 2, we actually are going to put that 3 here. Technically, 8 goes into 2 0 times. So if you wanted to think about a 0 right above that 2, you could. It's not necessary, but you can think of that 0 there if you'd like to. So we have 3 up top. 3 times 8 is 24. We bring that 24 down and we subtract. 24 minus 24, again, you can do the 4s and then the 2s, or you can look at it as a 2-digit number on top and bottom. So 24 minus 24, either way, you will get 0. So we bring a number down. Our next number is 8. So now we were looking at 8 and 8. And we want to know, is 8 divisible by 8? Well, yes, 8 is divisible by 8. When we do 8 divided by 8, we get 1. So we're going to go ahead and put a 1 up top here because, again, 8 divided by 8 is 1. 1 times 8 gives us 8. And then we subtract. 8 minus 8 is 0. And again, we bring down the next number, which is another 0. All right. Now, we can't stop here quite yet. Even though there's zeros here, we have to make sure that when we have a decimal or a digit, not a decimal, we have a digit left. When we have a digit left, we want to make sure that we have filled in all those spots up there. So 31 is not the correct answer because we're not finished yet. We have this empty spot right here. So that's why we line them up above so that we know when we're finished. If we were to get 0 somewhere along the way as we're subtracting, like here. So we are not finished yet. We still bring that 0 down. And now we are looking at 0 and 8. Now you might think 0 and 8, that's not going to work. But 0 divided by 8 is in fact 0. So 0 divided by 8 will be 0, and we will put a 0 right there. So that will be that last spot. And our answer for this problem will be 310. So on number 3, we have 337.70 divided by 5. So this time we have a decimal not in our divisor, not in the bottom, but actually in our dividend, which is in the top. So when we have a decimal in the top, first thing we want to check is there also a decimal in the bottom? If there were a decimal in the bottom, we would want to get rid of that decimal in the bottom first, and then we will worry about the decimal in the top. So I just want to make that note, and I'll talk a little bit more in a second about what happens if we do end up with a decimal in the top and the bottom. How do we work with that? And I'll detail that a little bit more with an example. But for now, we see that the bottom, the divisor, does not actually have a decimal in it. So we go ahead and set up our division problem, 337.70 divided by 5. And what we want to do, since we do have a decimal point in our dividend, we are going to go ahead and bring up that decimal point right above where it was in the dividend in our quotient. So we are going to have a decimal point there, and we will solve the problem just like normal, but there will be a decimal point there in our answer. So first thing we are going to do is look at this first digit, 3 and 5. 3 is not divisible by 5 because 5 is already bigger than 3. So then we go ahead and take a look at 33. Now, 33 is not evenly divisible by 5. So because we can't evenly do 33 divided by 5 and get a whole number, we are instead looking at how many times can 5 divide into 33 before it goes over that 33. So if you think about, for example, 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15, so on and so on. 5 times 5 we know is 25. If I go up another 5, so 5 times 6, that's going to be 30. But 5 times 7 will put us up to 35. So 5 times 6 is what gets us to 30, which is the closest to 33 without going over. So again, because that first number did not work out with the 5, technically there is a 0 there if you'd like to put one. Now we're looking at the 33, and we're going to put a 6 up here because 6 times 5 is 30. And that, again, is the closest we can get without going over 33. So now we subtract 33 minus 30, or you can do it column by column, either way, and we end up with 3. But we do need to bring down that next digit, that's 7. So now we are looking at 37, and we are trying to see if it is divisible by 5. 37 is not evenly divisible by 5. However, we can go ahead and see how many times 5 can be divided into 37 without going over that 37. So 5 times what gets us as close to 37 as possible without going over. Think through your multiplication facts. We just said 5 times 6 is 30, but 5 times 7 is going to be 35, which is even closer to 37, and we haven't gone over yet. 5 times 8 would put us at 40, which is over that 37. So 7 is going to be that next digit. 7 times 5 is 35, so we put that underneath here, and we subtract. 37 minus 35 is 2, and then we bring that next digit down, which will be a 7. So again, we go back to 27 divided by 5. 27 is not evenly divisible by 5. However, we can continue to see how close we can get without going over. Now, 5 times 5 is going to be 25. So I can put a 5 right here because 5 times 5 is 25. If I would have done 6 up there, that would put us at 30, which would be over the 27. So we have 25 right here, and we subtract that, which gives us 2. 27 minus 25 is 2. And we bring down that next digit, which is a 0. Go back to the same process. So now we are looking at 20 divided by 5. And this time it does work out perfectly. So 20 divided by 5 is going to give us 4. So we can put a 4 right here. 4 times 5 is 20. When we subtract there, we get 0, and we filled in all of those spots up top, and we have 0 down here, so that's how we know that we are finished. And our final answer is 67.54. So I want to go ahead and talk about what happens if both the numerator and the denominator of a fraction, or in other words, the dividend and the divisor, both have decimal digits. So for example, right here, if we had 0.444 divided by 0.2, we would not be able to jump straight to setting up our long division because our denominator has a decimal in it. So we would want to get rid of that decimal first, just like we did on this first example down here, by moving that decimal point however many digits over we need to no longer have a decimal. So if I move it over 1, I now just have a 2 on the bottom. But if I move it over 1 on the bottom, then I need to go ahead and do the same thing on top. So now I would have 4.44 divided by 2. And then I would be able to go ahead and set up my 4.44 divided by 2 and either do that in your head if you're capable of looking at all of those 4s and dividing those by 2 and understanding how that works, or you can set it up like long division and continue with the long division process. Either way, you would end up with this 2.22. So in summary, we have the long division process that we looked at with whole numbers and decimals in this video. So to start with long division, we set it up in this format with the dividend under the bar and divisor on the left side. And then our answer that we got as we went along went in this quotient spot up top. So we always divided by looking at the first digit here and the first digit in the divisor. And we divided. Once we divided, we placed that up here right above that first digit. Then we went ahead and multiplied that top digit by the divisor and placed it underneath that first digit. At that point, we subtracted those digits and got a new number. And then we continued to follow this process. So we brought down our next number, and then we continued to follow that process of dividing and multiplying, subtracting. Now the check part is just making sure that you did in fact pick the largest possible number to go here, so that when you multiply it by the divisor, you end up with a number, the difference right here once you subtract, that's smaller than the divisor itself. So that's the check part in this little cycle here. And then again, you're always bringing down that next number once you have that number from your difference. So you bring down that next number, and that's what you use to divide, multiply, subtract, check, bring down, so on and so on. Now, additionally, we looked at long division with decimals. So remember, if you have a decimal in your dividend, which is your top number of your fraction, remember, if that's the only place that has a decimal and the divisor is a whole number, then you just divide like normal. But when you set up your dividend and your divisor and your quotient, like up here, you will have to make sure that wherever your decimal point is in your dividend, that your decimal point goes in the same spot in your quotient. Now, let's say that your divisor was the only one that had a decimal out of your dividend in your divisor. Remember, if the denominator has a decimal but not the top, then we want to go ahead and take the divisor, and wherever the decimal is, so for example, the one we did, we had 0.8, then we moved it to the right 1 decimal point, and we have to move the decimal point 1 place to the right on the top as well so that it remains correct when we get our final quotient. All right, and then finally, if we have a dividend and a divisor that both have decimals, then we went ahead and did what we just talked about, where we got rid of the decimal in the divisor by moving that decimal point in the divisor and the dividend. At that point, once it's gone out of the divisor, it's okay that it has a decimal point, or if it has a decimal point in the dividend, as long as the divisor does not have one. So those are a couple reminders with our long division process with whole numbers and with decimals.